So the first lecture of this week was waste management. And if that wasn't quite dirty enough for you, here we are at toxic substances and hazardous waste. Yeah, this class we're talking about the really noxious stuff. A little bit of fun here on the left. And for good reason. We think of these as these, pretty gnarly chemicals that, well, maybe can't turn us into zombies, but can certainly be pretty scary. But they don't have to be that way. They don't have to be quite that nightmarish. And one example of how we can avoid that is the cartoon on the right, which paints a little bit more positive picture of at least the management of household hazardous waste. And just a reminder, this is the PSA for today's lecture, of the existence of household hazardous waste drop-off centers, I think in probably virtually every municipality. So, old paints and so on and so forth, that we can handle them appropriately. And of course, we have to have such centers because, we're going to spend most of this lecture thinking about toxic substances and hazardous waste at the sort of more industrial scale. We can find these in our homes, right? And I think this is a useful, informative diagram to show us just how permeating harmful chemicals are into the household. And so this one shows both where we can find them, throughout our homes in flame retardants, in the paints, in various products that we might cook with, even the things we might sleep with in terms of our, linens and so on. And also points to some ways in which we might avoid, because really in many ways that is perhaps the best option, is just to simply avoid these hazardous products to begin with. And on that note, this diagram should look familiar to you from the first lecture, thinking about how do we not just dispose, treat, whatever working at the bottom of that pyramid with waste in general, but toxics in particular, but how do we move up the pyramid towards avoiding using them in the first place. And just a reminder that we actually did talk about one way in the first lecture. I brought up this notion of cradle to cradle, this idea of thinking of materials and energy flows in a more cyclical nature, accounting for life cycle costs in a more holistic way in the first lecture. And there I was talking about how we might mitigate or reduce waste writ large. But of course, it can also be a very critical way to reduce the amount of toxic and hazardous chemicals in our products. At the very least, to confine them to product cycles where we continue to reuse them insofar as they're essential ingredients in our products. But just a reminder, thinking about this notion of cradle to cradle can be, I think, really useful way of framing a pretty substantial paradigm shift in waste reduction and, again, toxics reduction. So all of that said, the reality is we continue to have toxics released into our environment. Some might say that's a reality or a necessity of the industrial economy we have. Others might say, well, we're not doing nearly enough to reduce the number of toxics. Either way we cut it, at this point in time, toxics are being released. At the very least, the toxic release inventory does, however, exist because of the idea that we have a right to know what toxic chemicals are being released into our community, how they're being managed, and what their release looks like, and what ways or pathways they're being released through. So thousands of facilities across the country are required, mandated, to submit data on what they release to this inventory. And what they're releasing is over 650 chemicals and chemical categories that fall under the Emergency Planning Community Right to Know Act and the Pollution Prevention Act. So it's critical legislation in terms of stipulating that we at least have a right to know. And I'd be curious, a question at this point that I ask you, how many of you were even aware this exists and what data you might find there? I have the impression that most of us don't. I probably wouldn't know if I didn't have to do this work in the class. And that's probably telling in its own right. So we have this inventory. We can find out about the toxins being released. But do people use it? Does it inform our decision making? Does it help us to protect our quality of life? Those are really questionable. What happens to those toxins? Well, as the pie chart on the bottom left indicates, most of them end up being stored on site. And of course, that can be a good thing if they're contained well. It can be a problem insofar as they can be poorly managed, they can leach over time or leak over time. But that's the predominant way in which these releases are managed. Some is sent for off-site disposal, about 11%. 19% are released into the air. And about 6% are discharged into waterways. The inventory, as I said on the last slide, I believe, is about 22,000 facilities. There's about 25.4 billion pounds of waste that they're managed, and you can see the breakdown there roughly of what happens to those waste products. You might ask, who's responsible for these? What are the facilities? Well, this is a useful breakdown in terms of both water releases and air releases. So if we look at water releases, food, beverages, tobacco is the largest category there at 33%. Petroleum industry, 13%. Primary metals, higher, actually 17%. Chemicals, 15%. Paper, 9%. Gives us a sense of the big sources of water. Air, chemicals also pretty substantial there at 21%. Utilities even larger in terms of releases at 25% responsibility. Paper, again, fairly substantial. So we can see what kinds of firms are releasing the highest quantities of these toxins. So we talked about air and water on the last slide. This last pie chart here is showing us with land disposal. It's interesting because metal mining is such a dominant source of these releases when we talk about on land. And of course most of that is tailings, and so for those of you that aren't familiar, essentially when we mine metals, they're in relatively small concentrations. That varies a lot. The most precious metals, gold and so on, will be in tiny quantities within rock, and so we have to go through processes of extracting those metals from the ore, right, from the rock that they're contained within. And sometimes that can be quite dirty, for example, using chemicals like cyanide and so on to extract them or leach them. And what we end up with are huge tailing ponds. And by coincidence, today I was a judge on a panel of grad student presentations, and one of them actually focused on this very thing. So it was focused on understanding dam failure of tailings ponds dam failure, because unfortunately that's just all too common, and really unfortunate when it happens, because we can see these tailings full of very dangerous toxic chemicals released into the natural environment, flowing into, for example, waterways and destroying pristine waterways. And so it's actually a big deal, very big deal. But unfortunately, from mining, these tailings can just be a really dirty reality of mining, is that mines produce a lot of waste. As I said before, we know all of this because of the toxics release inventory, which requires fairly detailed reporting at a facility level, and that is completely accessible to all of us. So what I'd encourage you to do is check this out. If we were in class, I might ask you to do this as small groups, but since we're not, just take some time to do this. Even if you just type in, you don't have to look at that small source in the far right-hand bottom corner there. You can just type in a search of EPA toxics release inventory and play around with it. Where do you come from? What's in your area? What I did here was a search around Blacksburg, so 24060 zip code, a 10-mile radius. And as you can see, there are something like, I believe, 7 facilities that pop up. And I'm going to dig in more detail into what is the largest one here. And so, probably not surprisingly, after we talked about earlier semester, the largest TRI facility in terms of waste produced within a 10-mile radius of 24060 zip code is the RAP, is the Radford Armory. And we can learn some interesting things from the database. So if we look here, for example, in addition to contact info and so on, we can learn that they, in 2018 at least, released about 131 million pounds of toxins, that they are responsible for about 98% of the toxic release of the releases in the TRI. It says in Montgomery County. The facility is not actually in Montgomery County, as far as I know, but I believe it's in Pulaski. But I'm assuming the reason it says Montgomery County there is because this is out of the 9 facilities within the 10-mile radius of the search I did of the off the 24060 zip code. So I think that's actually an error. But nonetheless, out of the 9 facilities that were identified based on my search, this is responsible for 98% of them, which is a pretty substantial amount. And interestingly, it's actually the top producing facility of the 372 TRI facilities in the national security and international affairs category, so the highest in terms of releases. So we can learn some interesting information there. And so what are they releasing and where is it going? Well, as you can see, about 96% of the released chemicals are nitrate compounds. And as you can see, that's all going into the water. Therefore, because 96%, most of their releases by media are into the water. And we can see, interesting, right, that we have seen a decrease here over time of the releases. So, yeah, there's a downward trend there, fortunately. And there are, of course, various ways that we can manage toxics. At the bottom of the hierarchy, it's interesting. We see another inverted pyramid here. Would be of course, the disposal or other releases, right? And that's, of course, the least preferred for multiple reasons, not least being that that's how they enter the environment, right? The second worst or slightly better would be treatment, right? At least through treatment, we're reducing or eliminating some of the characteristics that may be harmful to humans and or the natural environment. Third would be energy recovery, where at least we're getting something out of, for example, as I said before, incineration. And we, in fact, we think of hazardous waste, not necessarily toxics, but hazardous waste like medical waste, often will be incinerated because it is a way to render it benign, kill off, obviously, viruses, and so on and so forth. And at the same time, concurrently, often we'll try to harness that to create energy, so that's great. Recycling it, if we can, and there's certainly lots of examples of that, thank God, of where we can take chemicals and recycle them, right? We recover the compounds that otherwise we might end up disposing or releasing. And last but not least is source reduction. And again, there we've seen tremendous progress, and we shouldn't downplay that. There's a long way to go, but there are multiple ways in which we can shift from dangerous chemicals to alternatives. When I say we've made progress, I want to give an example, because I think sometimes it's hard to appreciate just how profound the progress has been in some areas. I'll give you two examples around the same substance, and that's lead. So not that many decades ago, lead was found in two substances that might shock you. One is gasoline. I think that's probably the more shocking in some ways, because we burn the stuff in our cars. And so there's a reason when you go to the gas station today, it says unleaded. You might have wondered, why does it say unleaded? Can you buy unleaded gasoline? Doesn't it seem ridiculous? Well, yes, you could historically buy gas with lead. And in fact, gas always had lead in it. It had lots of lead in it. And you can imagine that was leading to emissions of lead into the atmosphere that was clearly not good for us. And the other would be paints. And so in some states, for example, where I moved from Massachusetts, there are actually very strict lead paint laws around to protect children, because there's actually problems with children eating paint chips that would have lead in them. And so really, until not that long ago, we would find lead in those products, and we phased it out. And so that's a good example of a source reduction of toxins. Okay, so if the gold standard is source reduction, it behooves us to think about what the barriers are to it. And some of these may be virtually impossible, at least in the short or medium term, to overcome. But others we arguably could, and so it's helpful to think about what is identified by firms as the barriers, so we can think about how we can address them or tackle them. I'm going to go through all of these, but if we think about the first few, the most common barrier identified is that there's no known substitute or alternative technologies. So example given here is a battery manufacturer that produces nickel-cadmium batteries. And therefore, given all the use cases for nickel-cadmium batteries, the arguments for why they're a viable product, it's virtually impossible for the firm to eliminate nickel compounds from their production. If we look at the second largest or second most common identified barrier, pollution prevention has already been implemented essentially. An additional reduction just isn't technically or economically feasible. So imagine here, for example, a fabricated metal manufacturer. They've already reformulated their paint booth linings, optimized their paint guns to decrease phenol waste. But they really couldn't go any further without just basically starting from zero or redoing the booths and so on at incredible cost. Next after that would be concerned that the product quality could decline as a result of source reduction. And we can all imagine that, right? So we imagine situations where there's a product that has a certain robustness because of an additive, or the manufacturing of it is more successful. There are less faults or blemishes because of a certain process. And therefore, we would see a reduction in that quality if we were to remove a certain substance or toxin. And those are just some examples. You can see here the other burdens are identified: insufficient capital to install new source reduction, specific regulatory permit burdens, requirements that technical information or pollution prevention techniques would be applicable to specific production processes. Source reduction activities have already been implemented but were unsuccessful, or things like customer demand. So those are just some of the things we see as barriers that we probably want to think about how we overcome. Okay, and so we've talked a lot about what these chemicals are, what these toxins are, where they're coming from, what they do a little bit, not too much, but a little bit about that. It's useful to appreciate the wide breadth of federal regulations that cover toxins. And the chapter, I believe, covers these pretty well. So I'm just going to give a very quick summary here, just to give you a sense of the breadth of different federal legislation that covers toxic chemicals. And so first one here is the Federal Insecticide, Fungicide, and Rodenticide Act of 1972 that requires that pesticides are registered with the EPA, labeled, stored, handled, and applied following certain standards. And the farmers, in particular, because they're the largest commercial appliers, have to take trainings, log their usage, and so on. It's hard to overestimate how important this was. I'm not sure this particular act was necessarily wholly responsible for it, but if we look at a chemical like DDT and the significant impact that it had on wildlife, for example, particular bird populations historically, and then we saw the reduction and ultimate elimination of DDT in particular, and just the profound impact that had in a statistical sense in terms of bird abundance returning to rural areas, agricultural areas where they had been, essentially wiped out. And that's really important. Second is the Toxic Substances Control Act. So the EPA has the right to obtain information from private companies on chemicals, can control or ban their manufacture, import, for example, of PCBs. In a way, that was a precursor, a 1976 precursor to the Emergency Planning and Community Right to Know Act 10 years later, which more specifically is what led to the toxics release inventory that we just talked about before. So not only does the federal government, does the EPA have the right to that information, but the EPA has a responsibility to share that information more broadly, and also to establish emergency response procedures for when things don't go well. The Pollution Prevention Act of 1990 is ultimately produced that hierarchy we talked about. We're promoting reduction, reuse, and recycling and of toxic chemicals and waste in general as an alternative to just thinking about the best ways to dispose of them. Going on, the first one here is a little bit out of order perhaps because it's actually not a federal act, it's an international convention, but it's a really critical one. So the Convention on Persistent Organic Pollutants, POPs, 2001, was an international agreement that banned 10 of the most odious POPs, persistent organic pollutants like PCBs, DDT, and so on and so forth, internationally, recognizing that chemicals like this have a global impact, and so it's critically important. Oil Pollution Act, again, getting back to domestic legislation, prevention and response to oil spills, including Oil Liability Trust Fund that basically pays for cleanup and so on when companies go insolvent as a result of a catastrophic event. Hazardous Waste Permit Program is part of the Resource Conservation Recovery Act, that essentially establishes a framework for cradle-to-grave tracking of hazardous substances, so from production all the way through to disposal, and sets standards on the identification and labeling, record-keeping, handling, operation of disposal sites, licensing of private disposal firms, penalties, and fines. And so, for example, if you're driving along the highway and you see a truck with a hazardous waste sign on the back of it, that's as a result of that permitting program. And last but not least, the Comprehensive Environmental Response Compensation and Liability Act of 1980, which identifies hazardous waste sites, maintains a national priorities list of the most polluted sites, the Superfund sites, and sets strict liability and responsibility. And that's where we're going to go next, is looking a little bit more at Superfunds, because that's a really big piece of dealing with particularly historical pollution. Okay, so I asked you to look at the Superfund website of EPA. And so hopefully you have a sense of this already, but it's just a map showing Superfund sites across the country. There are 13,000 hazardous waste sites in the U.S., across the U.S., plus thousands on military bases, but 1,700 are identified as actual Superfund sites. And what identifies are the criteria for a Superfund site is based on the likelihood that the site has released or has a potential to release hazardous substances into the environment. It's based in part on the toxicity and quantity of waste involved. And certainly last but not least, the potential for people and or sensitive environments to be affected by the releases. So those are the criteria that are applied when a site is identified as a Superfund site. And so what Superfund really is an investment program. It's a large-scale, billion-dollar set of projects that are designed to clean up some of the dirtiest sites we have, right, due to historical patterns of toxic waste released into the environment. And you look at the top chart here, you can see, so I mentioned 1,700. Out of that, where they are in terms of their statuses, you can see the number of active has been declined over time. Fortunately, the number completed has grown, and some have been deleted, so identified as no longer needing to fit that criteria of Superfunds. And as I said, it's about a $1.1 billion appropriation that is going through the cycle, and about $150 million that's available as of 2013, so a few years ago, available for investment. But yeah, it's an investment fund. It's a way that money is allocated or appropriated into a very specific use of cleaning up these sites, most of which were long ago abandoned, and so there's a real challenge in allocating responsibility to a firm that may have disappeared, may have been sold on to other firms, and so therefore that unfortunately the federal government has to be lined up to make these investments. And so I'd ask you to take a look at this video that's below this one, the supplementary video on the Wyckoff Eagle Harbor example, Superfund example, with the it's a cleanup in Washington State, and I think it's interesting. It's a good overview of what a Superfund cleanup can look like, and so please check that video out. But of course, there's Superfund sites much closer to home. The closest, I believe, to us is in Saltville. It's the Saltville Waste Disposal Pond. So the Olin Corporation ran a chlorine gas plant there from 1895 to 1972. And the waste generated by the plant are stored in 2 on-site ponds. Unfortunately, those ponds have contaminated the soil, the sediment, the surface water, and groundwater, and have caused contaminated accumulation in fish in the North Fork of the Holston River. So fairly substantial impacts going on there. Solutions have included, and this is where the Superfund money has gone, is to groundwater treatment, dredging, surface water diversion, capping those ponds, and additional investigations into what is going on. And I mentioned that a lot of this money is invested through the federal government, but the federal government does try to get companies to pay for previous damages when they can. So in this case, the Olin Company is paying $35 million in this second phase of the project here. So that was an overview of legislation in the United States, various acts that are relevant to toxic waste management in the U.S. context. But as I did at the end of the waste presentation, the first lecture of this week, I'd point you towards examples elsewhere in the world, in particular European examples. And so in the European Union, there are in particular a couple of directives that are related to toxics. The first would be REACH, which is registration, evaluation, authorization, and restriction of chemicals. So essentially it suggests that there needs to be good data on chemicals before they can be regulated. It places the responsibility on industry to manage the risks and to provide safety information. And it's managed through, just like we have the Toxic Release Inventory, they have the European Chemicals Agency Central Database. So in some ways, something similar. The WE directive probably is a little different than what we would have here, and I think I maybe mentioned it at the end of the first lecture. But essentially it requires firms to collect and deal with their electronic waste. So producers have a responsibility to essentially recover post-consumer their electronic goods. And so it's really interesting. It places that responsibility on manufacturers and distributors. So if you go to a electronics store in Europe, you'll see a place where you can take your old phone and deposit it, because it's their responsibility to figure out how to deal with it. Just some final parting thoughts would be, I guess, to ask you to reflect on how much we should tolerate toxins in our environment. I think it's really easy for us to say toxins are inherently bad, which they are, and therefore there should be zero. That's not the approach that historically has been taken, right? So toxicologists, for example, would say it's all about dosage, right? And that there is a threshold above which something is dangerous. And for the most odious things, that threshold is extremely low. And for other things, it maybe is higher. And so that really what matters is dosage. That's the way that typically we have thought about toxic releases. We have not completely prevented them. Instead, we've set those thresholds. We've said what is an acceptable dosage? What is a dosage below which we can expect reasonable degree of public safety and health, recognizing that there are going to be impacts and costs, but what is quote-unquote reasonable? And of course, there are trade-offs around how strongly or weakly we regulate. That's just a reality, as it is in many of the topic areas we're looking at this semester. So how much is enough? How much is too much? Those, of course, are discussions that require deliberations, right? That's why policymaking around things like toxic chemicals, just like many of the other things we covered this semester, are by nature, and should arguably by nature, come down to deliberations between multiple stakeholders, right? Whether that takes the form of lobbying, I personally think lobbying is probably not the most effective way to do it, but it's been the norm, or through other forms of multi-stakeholder deliberation where we can get the actors in a room to deliberate. But fortunately, we have environmental advocacy groups that are willing to make the case for why these should be reduced. We can expect industry groups that will do the same. And as I say, at the end of the day, there is no 100% right or wrong answer. Instead, these are deliberations that people have to have.